Tonight, you'll probably glance up at the moon without thinking twice. Maybe you won't even notice it's there. It's just background, a pale circle you've seen 10,000 times before. But the real answer is far stranger. If that circle vanished tomorrow, you wouldn't just lose a pretty light in the sky, you would lose the thing that built you. Start with your day, your sleep, your tides, your seasons, all of it, quietly held together by a rock 384,000 kilometers away. You've never had to think about it because it's never changed, but it almost didn't exist at all. Roughly 4.5 billion years ago, a Mars-sized object slammed into the early Earth. Scientists call it Theia. The collision was so violent it liquefied both worlds. Debris from that impact, molten rock and vaporized metal, spun into orbit and slowly clumped together. That debris became your moon. You are, in a very literal sense, living on the survivor of a planetary car crash. And the wreckage above your head has been quietly stabilizing your life ever since. Here's what most people don't know. Earth wobbles. Like a spinning top losing momentum, its axis tilts and drifts. Without the moon's gravity holding that tilt steady, Earth's axial tilt could swing wildly over millions of years, from nearly 0 degrees to over 60. Planetary scientist Jack Wisdom modelled this in the 1990s. His simulations showed that a moonless Earth could tip almost onto its side. Imagine a planet where the poles sometimes point directly at the sun, where climate doesn't shift gradually, but violently, over geological time. Winters that last centuries. Summers that melt continents. Would life even survive that? Maybe, maybe not, but it certainly wouldn't look like your life. Now think about the ocean outside your window, or the one you visited last summer. The tides pulling in and out, twice a day, like clockwork. That rhythm isn't random, it's the moon, tugging at Earth's water as it orbits. Without the moon, tides wouldn't disappear completely. The sun still pulls at the oceans, but solar tides are less than half as strong as lunar ones. The coastal rhythm you've built vacations around, the rhythm that shaped estuaries and mangroves and the first creatures that crawled from sea to land, would shrink into something barely noticeable. And that matters more than you'd think. Some researchers, including biologists studying the Devonian period, have proposed that strong tidal zones may have helped push early fish onto land, stranding them in shallow pools that forced lungs and limbs to evolve. No one claims the moon single-handedly created humanity, but it may have nudged the timeline. Without it, evolution might have taken a very different, much slower path. You might not be reading this at all. Something else might be. There's another piece of you, quieter, harder to notice. Your internal clock. Not just your sleep cycle, but the deep biological rhythms tied to roughly 24-hour and even lunar month patterns. For decades, scientists debated whether the moon directly influences human sleep. In 2013, researcher Christian Kayochan ran a controlled study, sealing participants in rooms with no clocks, no windows, no way to sense the moon's phase. And yet, sleep quality dipped slightly around the full moon. Deep sleep dropped by about 30% on those nights. The effect was small, but it was there, hiding in bodies that had no conscious way of knowing what phase the moon was in. Nobody fully understands why. Maybe it's an evolutionary echo from ancestors who once relied on moonlight to navigate, hunt, or stay alert to predators under a brighter night sky. Maybe it's coincidence dressed up as pattern, but it raises an uncomfortable question. If the moon can quietly touch your sleep without you ever perceiving it, what else has it shaped that you've never noticed? Picture the sky itself on a clear night away from city lights. The moon isn't just an object up there, it's a stabilizer of darkness. Its glow, faint as it seems, has shaped the behavior of nocturnal animals for millions of years. Moths navigate by it. Sea turtles hatch and crawl toward its reflection on open water, mistaking any brighter artificial light for the horizon. Remove the moon, and you don't just get a darker sky. You unravel migration patterns, mating cycles, and predator-prey timing that stretch back further than humans have existed. And what about the length of your day? Right now, a day is 24 hours because the moon has been slowing Earth's rotation for billions of years through tidal friction, like a brake gently dragging on a spinning wheel. Long ago, a day on Earth lasted only about 6 hours. Without the moon continuing that slow drag, Earth's rotation would stay faster, or at least stop decelerating at its current gentle pace. Your 24-hour day, the one your entire life is built around, work, sleep, meals, meetings, exists specifically because that rock has been quietly breaking the planet since before life crawled out of the ocean. So if the moon vanished tonight, what would tomorrow actually look like? Tides would shrink to a third of their current strength within days. Nocturnal ecosystems would begin destabilizing within seasons. Axial wobble wouldn't show up immediately, that unfolds over hundreds of thousands or millions of years, but the process would begin the moment gravitational anchor disappeared. And somewhere in a sealed sleep lab, if Kajochin's research holds any broader truth, human sleep patterns might shift in ways too subtle for anyone to consciously notice, the same way they never noticed the moon shaping them in the first place. Here's the part that should sit with you the longest. You've spent your entire life assuming stability. Assuming the ground, the tides, the seasons, even your sleep, are simply how the world naturally is. But none of it is neutral, none of it is default. It's the outcome of a Mars-sized object hitting Earth billions of years ago, and the debris happening to settle into an orbit stable enough to last this long. Physicist Jihad Tuma, who studied planetary spin stability alongside wisdom, noted something worth sitting with. Moons like Earth's, the kind large enough and close enough to meaningfully stabilize a planet's tilt, may actually be rare across the universe. Most planets, if they have moons at all, may have small, distant ones incapable of doing this job. Earth may be one of the fortunate exceptions. A planet that got a stabilizing partner almost by cosmic accident, which means the version of Earth you live on, mild seasons, predictable tides, a 24-hour day, dark nights lit just enough to navigate by, might not be the normal outcome for a planet like this one. It might be the rare outcome, the lucky one. So tonight, when you glance up and see that pale circle again, you probably still won't think twice. But now you know what it's actually doing up there. It's not decoration. It's not just something poets write about. It's the quiet reason your seasons don't swing violently. The reason your coastlines have a rhythm. The reason your night sky isn't pure blackness. And maybe, in some small way, you'll never consciously feel the reason you sleep the way you do. The real answer was never in the sky. It was always underneath it, in you.